Hi guys, welcome to another video. So today we're going to be looking at how to forecast your data in Power BI. Now, of course, there are all sorts of external tools that you can use for producing a forecast, including Azure Machine Learning or using Visual Studio Code and then writing Python in order to produce some kind of forecast. There's all sorts of ways, but that is all going to add a lot of complexity to your setup. So what we want to do today is just use Power BI and then of course DAX. So stay tuned. So our goal is to produce a forecast given the data that we have up till now. So this is our historic data. We have revenue numbers for the past 5 years. And what we want to produce is a forecast using this data. So we're going to use the LINESTX formula. So that is a formula that is going to leverage the least squares method. The least squares method, what that comes down to is that the engine is going to determine the line that would fit this data best and therefore would have the least distance between the line and all of the data points. So it takes the square distance from the line that it's going to produce and all of the data points themselves in order to also accommodate for negative distances. Okay? So we don't need to understand the least squares method. That is just going to be taken care of by Microsoft below the hood. So what we do need to understand though is the LINESTX formula. Now the best way to show how that works is to do that here in the DAX query editor. So I'm going to evaluate. We need to produce LINESTX. We need to supply LINESTX with a table. So I'm first going to show you how the table would, how you would arrive at the table. So we're going to take the dim date. Summarize. Summarize is kind of like a select statement in SQL. Yeah? So we start off by the base table, which is the dim date, and then we're going to say the year month index. If you do not have an index yet in your date dim calendar table, then I would highly recommend that you do, because that makes life a lot easier here if you want to forecast. And then for the revenue, we're just going to take our total revenue measure. Yeah, so total revenue. So this will give me that particular table. We need to we can still order it. So to get a better idea, order by, and then we take that year month index again, and then you'll see that what we get here is simply the table that is used for this here visual. Yeah, the data is the same. This is just a visualized expression of it, but the data is still the same. Now, as you can tell, there's also blanks here. We want to take those out. So let me go ahead and filter those out. So this is like a where clause in SQL if I use filter. So now we're going to say filter where not is blank, that total revenue measure, right? If that evaluates the blank, we don't want that in our result. So this is the table that we want to supply to LINESTX. So let me go ahead and do so. So I'm going to include that LINESTX formula here, LINESTX, and as you can tell, it first requests a table. So the first parameter of this syntax is a table. Well, that will be the table that we just produced, yeah? So that is why we just written this table. So here goes. And next, so this we don't need anymore. So next, it's going to say, well, give me the y expression. So those are the actual values, yeah? So that is our revenue that we just created. And then the x expression, well, that is that year month index, yeah? Those are the values on the x-axis. So now if I run this query, what we'll find is that we end up with a table with one row. Yeah, so this one row is going to give me all of the statistics of the line it first determined. So the engine executed the least squares method to determine the line that fits best, and now I get all sorts of statistics. The ones that we are interested are these two, the slope and the intercept. So once we have the slope and the intercept, we can determine the y value for any point on the chart. So I have a very simple example here. So the formula for determining a y value is the slope times the x value plus an intercept. Yeah, so we have been provided with these values by the LINESTX formula. So we just have to fill out the formula and then we would get our result. Yeah, so if this is our formula, the slope times the x plus an intercept, if we know that the slope is 2, what that comes down to is that for every increase in x value, the y value comes up by 2 values. And the intercept is actually just the point at which it crosses the y-axis. Yeah? So if we have these 2 values provided, then we can determine the y value for any point on the x-axis. So next, we just need to do that. So we need to do so in a DEX measure. Yeah? So I'm going to head over back to my report view. I'm going to create a new measure. And now let's be optimistic and call this forecast. We need a few variables though. So first what we need is that the output from the LINESTX formula, so we can take the slope and the intercept. So let me go ahead and copy the formula that we just produced, so I don't have to rewrite that. So I'm going to just copy this formula, go back to the forecast and say, well, the variable for, well, I'm just going to call this line equals all this. Yeah? So then var for our a, so a is the slope. Yeah? So what we're going to do is say, well, we want to select a column from that line, and it's called slope 1. That is the name of that column. So what the engine is going to do, if we select a column out of a table that only contains 1 row, we'll end up with just 1 row and 1 column. The DEX will convert that into a single number. So that should work just fine. So we can also already see if that works. So if we just return this from our formula and add the forecast, let's turn this into a table for now. So if I add that forecast right now, all I'm expecting to see is the slope. It's not doing that though. So let's look at the formula here. And so what we have here in our table is only the year month index. So we need to also include here the dim date, the year, and then the month name as well as the month. Yeah, because I've ordered the month name by the month column. So we need to include both, even though we're only using month names in our tables. So now I am expecting yes. So now we get to see. So it's not the forecast yet, of course, right? Or the only thing that we determined so far is just the slope. So now we got the slope returned. So we can continue here now and say for our B, that is the intercept. So that is the same formula as this one. But now instead of the slope, we want to call that intercept. Yeah, so now we can check if that works. And we get this here value. So that indeed is this value. So this is where it crosses the y-axis. And so now what we can do next is say, well, the x value. So that is simply the value that on the x-axis the formula is getting executed for. So that is the selected value of whatever we have on the x-axis. Yeah? So var x equals selected value of that index, yeah, the year month index. And so now we have all of our parameters for the formula. So var y equals, so it's a times x plus b. That is the formula. Yeah? So now we can call that y, and that should be the result from our formula. So let's go ahead and do that. So now if we, oh, it's already did. Let me format it the same way the revenue is formatted. Here we go. Now this is a little hard to see, of course, so I'm gonna turn this into it. There we go. So this looks a lot better. Yeah, this is the trend line that we managed to determine through LINESTX, and we have this now go into the future in 2026. But we still need to account for the seasonal pattern. So now let's go ahead and determine the factor, right, for our seasonal correction. So if we take the, well, I can use this here again, but I want to just add this into a matrix right now. Let me remove these values that we have currently. So we're going to say, well, I just want to have the average of all months. So let me go ahead and start off by determining that. So seasonal correction equals so average X of all of our year month index, and then we take the revenue, the total revenue. So this should give me the same number for every single month. All dim date. Yeah, but of course I need to also add the year, dim year, date, the month, and the month name. Same reason, yeah, if you sort a column by another column, you need to provide both if you want to have a filter removed. So this is the average of all months. So next what we need to determine, let's just enter variable average all, and then so we're gonna add a second variable var average month. So we're going to say, well, we want to have the average X. Yeah. But now we're going to filter this. So it's going to be the same. It's going to be the same table. We're going to filter this down to whatever month is in the filter context. So whatever month is on the x-axis. So what we're going to see, what we're going to say is month. So the dim date month equals the selected value of the dim date month, and then we do want to have that total revenue. So now let's call this first just to see if this works. So return average month. Yeah, see if we now get the average, because I expect here and there to see the same value every single time, yeah? So now all we need to do is just divide the two. So return divide the average month by the average all, and this should give us a seasonal, yes, here we go. So this is what we need to multiply our values with in order to also accommodate for that seasonal pattern that we have in our data. So let me go ahead and do that. So seasonal correction, the forecast, and we're going to multiply this by our seasonal correction. Here we go. And now we have a forecast for 2026.